Imagine a portrait that not only speaks, but can turn its head, shift its gaze, and move naturally from any angle, all while preserving the identity of the original subject. This isn't science fiction. It's the core promise of STARCaster, a groundbreaking video diffusion model that unifies speech-driven animation and continuous free viewpoint synthesis in a single, identity-aware framework, without relying on explicit 3D representations. At its heart, STARCaster rethinks how we approach talking portrait generation. Traditional 2D models depend heavily on reference images, often leading to static, repetitive animations where the face barely moves beyond the initial pose. Meanwhile, 3D-aware methods attempt to reconstruct a subject in 3D space using techniques like NeRF or Gaussian splatting. But these approaches require multi-view data or extensive test time optimization, and they're prone to identity drift and reconstruction errors. STARCaster sidesteps these limitations by embracing a compositional, spatio-temporal autoregressive design. It begins with a strong identity prior, leveraging Arc2Face, a pre-trained image diffusion model that uses ArcFace embeddings to encode identity with exceptional fidelity. This identity is preserved throughout the entire video generation process, enabling subject-consistent yet highly expressive animations, even when no reference image is provided. But how does it achieve view control without 3D? Here's the key insight. Video data inherently contains multi-view information. By training on synthetic 3D head models rendered along smooth camera trajectories, STARCaster learns consistent spatial motion patterns. These pseudo-multi-view sequences act as a proxy for 3D awareness, teaching the model how facial features should change across different angles, even though it operates entirely in 2D. The architecture itself is carefully designed for disentanglement. A frozen 2D UNet backbone, inherited from Arc2Face, handles spatial detail and identity fidelity. To add temporal coherence, we insert lightweight temporal transformer blocks after each spatial attention layer. These operate along the time axis, allowing each frame to attend globally across the sequence, enabling long-range temporal dependencies without sacrificing speed. Crucially, STARCaster uses a decoupled multi-source cross-attention mechanism. Instead of blending identity, audio, and camera conditions into a single stream, it maintains 3 parallel pathways, one for identity via ArcFace embedding, one for audio via WAV2Vec, and one for camera pose encoded as extrinsics and intrinsics. Each modality influences the generation independently, preventing interference and enabling fine-grained control. But here's where it gets really powerful: self-forcing autoregressive training. Most diffusion models use teacher forcing, training on perfect ground truth context. But at inference, the model must rely on its own predictions, leading to cumulative errors and overly static output. STARCaster solves this by training with self-forcing. During training, the model uses its own generated frames as context for the next segment, not the real ones. This forces it to learn how to correct its own mistakes, implicitly modeling longer temporal dependencies than its receptive field would normally allow. The result: more natural, dynamic, and expressive motion. To further refine lip synchronization, we introduce lip-reading supervision. A pre-trained lip-reading network, trained on LRS3, extracts perceptual features from the mouth region of both ground truth and generated videos. A mean-squared error loss between these features ensures that the model's articulation closely matches the driving audio, going beyond simple photometric alignment. This is especially critical for realistic speech animation. Training happens in 3 progressive stages. First, we train the model to generate natural facial motion driven purely by audio, using identity and lip-reading supervision. Then, we enable autoregressive self-forcing with reference conditioning, fine-tuning the LoRa modules that modulate attention to the reference image. Finally, we deactivate the audio stream and adapt the model for view synthesis, training it on synthetic multi-view trajectories to learn spatial consistency. At inference, the flexibility is stunning. You can generate a talking portrait from a single image, using only audio and the reference frame. Or you can skip the image entirely and use only the identity embedding, allowing the model to generate novel, recontextualized animations of the subject in entirely new scenarios. Want to see the subject turn their head from side to side? Simply interpolate between camera poses and animate along a smooth trajectory. Evaluation confirms its superiority. On benchmarks like TH1KH and Halo3, STARCaster achieves state-of-the-art results in FID, FVD, lip-sync accuracy, and motion diversity, outperforming even large-scale DI-T models. In free viewpoint generation, it surpasses 3D-aware baselines on NeRFs, achieving higher image quality and better spatial consistency, despite being conditioned on audio rather than driving videos. Ablation studies prove the importance of each component. Removing lip-reading supervision leads to less accurate lip movements, while disabling self-forcing results in flatter, less expressive motion. STARCaster isn't just a technical achievement, it's a paradigm shift. It demonstrates that 3D-aware video generation doesn't require explicit 3D representations. By combining strong identity priors, video-based spatial consistency, and self-forcing training, we can achieve rich, free-viewpoint talking portraits using only 2D diffusion models. Of course, challenges remain. Inference is still slow compared to GAN-based methods, and background motion isn't yet supported. But this work opens a new path, one where foundation models can learn spatio-temporal consistency directly from data, not from geometry. In a world where digital avatars are becoming more lifelike, STARCaster brings us closer to truly animated, recontextualized, and view-aware portraits, powered not by 3D reconstruction, but by the inherent structure of video itself. This is the future of audio-driven facial animation, unified, expressive, and free.